Okay, hello everyone. Welcome to this session number 454. And today I will continue with this problem in rescheduling meetings for the maximum free time is, was a part of the last big weekly contest is this. The difference with the first is in essential in this is possible remove n it's possible reschedule n elements. No, in this case is k elements n, but keeping the relative order. And in this, version, it's valid for the relative ordering of the meetings to change after rescheduling one meetings. Means that I can modify the order of the elements like this. For example, if I have this in 1, 2, and this, for example, if I can move this directly in this point to have this free time as a result, okay? And the difference with the first version of the reschedule meetings for the maximum free time, this is not possible. I can move this meeting between the spaces, but not change the order. Okay, this is in essential the difference between these problems. Yeah, because in essential is the same statements and all of them. But well, now let me try to remember the idea that I was following in the morning. Okay, I think the first is to take the space, the longer space where, or the space, or the blank space where appear only one meaning. Yeah. In this case, for example, here, this is one. Another is starting here and ending here. Is until find another. This is a new, and well, the last, in this case, the last don't have nothing. Is between this and itself, means that nothing. And it search what is the longer space. In this case is this. Is this space. Yeah. But the other condition is that I need to search one space. It doesn't matter where, but it's necessary to find this space. Let me remove this. Search or find one space that allow move this. For example, in this case is here. If I move this square in this, and the final, the result is 1, 2, 3, 4, 5, and 6. Yeah, that is this. Okay. For this, I think that I'm not sure if it's with the sliding windows. I'm not sure. Because I can start here. No, sorry. Here. Yeah. And ask the previous and the next. Yeah. Is the total of the max blank space, and only if after this point, sorry, is, well, yeah, only if after this point I can find one blank space of the size 1. In this case, yeah, because I have this or this. It doesn't matter where, sorry, only matters that have one space of the t size. In this case, for example, yeah, it's possible, means that here the maximum is 1, 2, and 3. Yeah, and for example, now the next that is this. Now the limit is between this and this. And now I need to search one space after this line and before this line that allow this size. In this case, here is possible, and in this case, it's not possible, but it doesn't matter. It means that I can move this here, and the size is 1, 2, 3, 4, 5, 6. Previously was 1, 2, 3, but now it replaces by 6. Okay. Okay. Now the next that is this. Means that this is the limit. And now I need to search one space after this line and before this line. In this case, after this line is possible? No. Before this line is I have one empty slot. Yeah, I have two. Means that I can move here. I don't need to decide in which side. It's only enough to validate if exists. In this case, 1, 2, 3, 4, 5, because this is moved to this space, for example. 1, 2, 3, 4, and 5. 5 is greater than 6? No. Okay, in this case, the maximum number is this. And even for the last, okay, for the last, I am here, and okay, I need to discover, I need to validate if I can move this before, after this line is possible move this square. No, because it's the limit. And before this line is possible move, yeah, I have many slots. Well, means that I can move this in this side, and the size in this case is 2, 1 and 2. 2 is greater than 6? No. Okay, the maximum is 6. Okay, now I think that makes sense. Okay, makes sense. But now, how can I translate this as a algorithm? Okay, sorry. Okay. Now, how can I know this? I had the idea to use the prefix zoom, but in the morning appear a few things that don't make sense. For example, here, until this point, the maximum size that I can search, no. Okay, L to right. In this case, the maximum is 0, 0, because it's this. 1, that is this. 2, 1, 2, now not sure if this is 2. I think that yeah, because is this okay? In this case, is 2, 3, 4, 5, 5, 6, and 6. Means that the maximum. No, 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 no. This is wrong. 0, 0, 1, 2. That is this. Now the next that is this square. Here start again. 1, 2, 3, 0, 1, 0. If I am here and I need to know in the right side I have one element, no. Okay. 0, 0, 1 slot, 2 slots, 2 slots. Before this point, I have 2 slots. Okay, here. Okay, it's a new count. 0, 1. 1 is greater than 2. No, okay, the maximum is 2. 2 is greater than 2. No, the maximum is 2. 3 is greater than 2. Yeah, it's 3. Now this is 3. Now here is this is 0. Sorry, this 3 is here. Now the next that is 1. 1 is maximum that 3. No. 0. 0 is maximum that 3. No. Okay, we have this length, and now this is in the direction left to right. Now is right to left in another color, even right to left. And now here is 0. 0, 0, 1. In this case, this is 0. Between 0 and 1, the maximum is 1. Now here is 1. 1 and 1 is 1. In this case, this is 2. Between 2 and 1 is 2. Now the next that is between 3 and 2 is 3. Now the next that is 0. Between 0 and 3 is 3. Now here is 1. Between 1 and 3 is 3. Now the next that is 2. Between 2 and 3 is 3, the maximum. Now here is 0. Between 0 and 3 is 3. Okay. Now okay, here. Okay. Now the next is use this and start for the beginning. Okay, the first is this, right? And the limit are between the previous blank space and this, yeah? In this case, we have one in here, in this point, and I need to ask if in the in this case is for the right side is the green. Since at this point, yeah, I have one the counter is greater equal to 1, yeah, because it's 3, means that in this point starting here and ending here I have one space with the maximum of 3, that is this, yeah. In this case, is possible. And now the maximum value is this. Or in this case, for the left, I need to ask in this point, that is the black color, I have 1 equal greater 1. No, because it's 0. Okay, means that only in the right side I have one is the space that move this. And in this case, the length is 1, 2, 3. Okay, now the maximum is 3. Got it. Now the next that is this color. I don't know which color is orange, I think. Here. Now I am here, and I need to ask. In this point, I have one space of the size 1 greater equal to 1. In this case, no. Okay, now in the right side here, I have one space. Is the green? Sorry, I have one space that contains at least 1. Yeah, is this okay? Means that I can move in the right side, and the answer is 1, 2, 3, 4, 5, 6. 6. Okay, this is greater than 3. This disappear. And what is this? Now the next that is this. Okay, the yellow, I think. Now is in this point and in this point. Now, okay, the first for the left side, I have one space of the size 1. Yeah, even the maximum is 2. Okay, I can move in this side, and the answer is 1, 2, 3, 4, and 5. Okay, and in the right side, I have a space. Let me check. No, okay, the value is 5. And it's done. Now it's time to check the last. Okay. Now we are in the last. In this case, after this point, I have one element of the size at greater equal 1. No, because it's 0. Okay, now in the left side, I have one element greater equal 1. Yeah, I have even 3 blank space. Okay, means that I can remove this, and the space, the longest free time is 1 and 2. In this case, 2 is not great that also. I cross. Okay. Now the answer is 6. No. Between this. Makes sense? I think that works. Okay, now I think that the more complicated is this. Make this calculus. What can I do? Now for the identify, for example, if I am here, let me check the constraints. And okay, I can have an array of this size because is many memory. Oh, I think that I can use a, yeah, an array. I think that, yeah, or one list with this, with the this value, this. Let me think. In this case, the first. So you imagine that is this, okay? This is the list. Right. Now the first is a meeting. I think I can use an array for define where is a meeting, the value is 1, and the size. The size is 1. Now the next that is a blank space. Nah. I can use less 1, and the size is 1 and 2. Now the next that is another meeting. 1 and 1 is the size. Now the next that is a blank space. In this case, the blank space is well, let's 1 and sorry, it's 1 and 1, 2, 3. 3. Right. Now now the next that is this, right? One because it's a meeting and the size no the size is 1. And now the last is no, sorry, is this blank space. In this case is less 1 and the size is 1. And now is this, the last is a meeting. 1 and the size is 1. And now I need to start with the first and check is a meeting. In this case, yeah. Okay. Is a meeting means that before this I have let me think. This is the square. Okay, the green, it's equal number, and this is equal to free time. Okay. Okay, the first is a square, the size is 1, and and after it's an array. In this case, this is the size, this is before, and this is after. After. AF, only A, after. In this case, before this, the maximum value in this case is 0. I don't have anything. And after is 0 too, because first is in this direction. Yeah, okay, got it. Now the next that is a blank space. Okay. Size. Well, in this case, it's the same because it's the same structure, but the results are 0, 0, 0, and in this case, the size is 2. That represent this. Now, the next dot is this square, SBA. Okay, in this case, SBA. And in this case, the max size or the max empty size is 2, is this. Okay. Now the size of this is 1. Before this, the maximum value is 2. The maximum, and after is 0 because I am doing left to right in this moment. The next is this blank space. The size is 1, 2, and 3. The 3. In this case, between 2 and 3 is the 3. The maximum is 3. Okay. In this case, is the 3. Got it. Now, the next is this. The size is 1 and back is 3. And after is 0. I am saying that before this, I have one slot of 3. Is this. And after this is this. Is 2. Sorry. Okay, I think that every blank space can contains one element extra. Or even I can use one of these, but do you imagine that have another? That this is the maximum previous to this. In this case, the maximum previous to this is 0. Now, the maximum previous of this is 2, because between 2 and 0 and 2 is 2. Okay. And in this way, where I perform this operation, when I perform this operation of take this and ask before this point is possible, I have one space of the size 1 is only check the previous, and use this value. In this case is 0, means that I can move in this direction. Yeah, the maximum is take this, and in this side, for example, do you imagine that it's only checking for the left to right? In this case, is in looking in the left side is not possible. Means that I can reschedule this in another side before this point. And in the right side, I think that is the same. Okay, I think that I can use the back as uh, as a parameter for this. In this case, previous to this point, what is the maximum slot or the maximum free blank space that I can search, or I can find, sorry, is 0. In this case, the maximum is 2, and 1, 3. Is this? Well, do you imagine that M here, and only I have this, and in the right side is the same. Is update this and ask, for example, if I am here, is search the first blank space that I found, and ask if in this point the maximum value is of the size this. If it's minor, means that it's not possible, and check in the right side. Mm. Mm. I don't like the idea to search, iterate. For example, if I am here, uh, transversal in this direction, this until find one blank space, and the same in the right side. I think that should be much better if I only consult before the second meeting what is the maximum value. In this case, is this? No. Yeah, is this? I don't know. I have a few ideas in my mind, but no. But well, I think that it's enough for this short transmission, and I hope see you in the next. Bye bye.